everyone. I hope everyone's having a great night. My name is Melinda Wanis. I'm currently taking current issues of spring 2019. This is my first time taking the course. My final presentation is going to be on the impact and potential effects of P minimum blooms in the Chesapeake Bay. So starting off, we have the actual species being talked about. It's actually an important species. They are primary producers, and if you're not familiar with primary producers or you forgot what it was, they're pretty much at the base of the food chain, and how they work is larger animals in the food chain actually need primary producers to be alive, considering primary producers feed primary consumers, which feed secondary consumers, which then feed the top predators of the food chain. So while they could cause some harm, which you will see in the study, they actually are important and they are needed. So we'll get into how to moderate them more than get rid of them. So, let me get myself out of the way here. So if you can see, here's a picture I found. All references of photos are placed at the end of the slide, so I'm not taking credit for anything of these photos, but as you can see, they have like a brownish tint to them surrounding the coast. There are actually harms of these blooms, unfortunately. They can cause fish mortality, they can cause loss of aquatic vegetation, so like vegetation that occurs in our oceans or any type of bodies of water. They can actually impact us humans if we ingest contaminated creatures like shellfish or anything found in these waters. So this paper done by Dr. Tango, as we can see in the results, they define blooms as reaching cell densities of 3,000 milliliters across all seasons, but it was actually found more in April and May. If you can see right here, I've boxed all the most important, or not the most important, but the most abundant of P minimum in this paper. These events have averaged up to 15,000 organisms dying, so they have a harmful impact on our environment. These fish died due to low dissolved oxygen, diseases, entrapment, spawning stress, anything to do with how blooms affect our oceans. And a lot of species are affected by these blooms, actually. As you can see here, it's not just shellfish, as most papers use that common example. It's actually quite a lot more than that. Now, why are these blooms so harmful? Because P minimum is actually a natural primary producer, it's not their fault that they're causing such harmful effects on our oceans. What's causing these blooms to be so harmful is actually pollution. It's our doing. Pollution is due to a lot of inorganic nitrogen affecting our waters, results in acidification of fresh waters due to hydrogen ions being concentrated in those areas. These toxic levels can cause harm to any aquatic organisms developing, and the enhancement of primary producers can cause that food chain I was talking about before to be out of place. These can cause blooms by eutrophication, and eutrophication is when nutrients in a body of water become so rich and thick, it actually causes a growth of algae and depletes oxygen in waters. This paper did give a great start to the discussion of harmful blooms. However, it didn't really go into possible solutions for the future and how to prevent blooms from expanding even more. So when I looked up similar studies, this has been a problem for a while, as we can see here in a study done As you can see in another study done by Dr. Gilbert and their colleagues, from 1985 to 1996, during most summers, nitrogen concentrations actually raised by 30%. So where does this pollution come from? Well, it comes from us, unfortunately. As you can see here, there are a lot of point sources where nitrogen can come from. This includes wastewater from livestock and releases from agriculture and many other examples. Now, this study not only introduces the fact that nitrogen has increased by 30% in our waters, but it also talks about how that affects P minimum and how P minimum affects our waters as well. So since P minimum prefers ammonium and urea over nitrate with more of a nitrogen concentration, the nitrogen requirements for these blooms are easier to reach. As the study continued, we can actually see that these nitrogen concentrations increased 10 times as much in 1999 and has only increased from then. Now, while that does seem pretty scary, in another study, P minimum is actually shown to be harmful to some species, but it affects species differently. For example, if we talk about oysters, some studies have found high mortality rates in oysters exposed to P minimum over 10 days, while other studies found P minimum to not affect oysters even if they were exposed for 12 days. Oysters are secondary consumers that consume primary consumers that consume primary producers. With that being said, P minimum in high densities or prolonged blooms can cause oysters to suffer detrimental consequences, but P minimum in moderate situations can actually cause oysters to thrive and survive more. Therefore, action, in my opinion, must be taken to moderate P minimum blooms. So instead of getting rid of the species as a whole, we can simply moderate them and ensure that they're in their natural state of being to not cause such harmful blooms across summers or all seasons. Now, again, the paper was a great opening to this discussion. However, it didn't go into solutions. So when I went into some research of my own, I was able to find some solutions that can actually help with this problem. The first solution is antimicrobial peptides. They can manage blooms because they go over toxic algal species, but they leave harmless algal species alone. This is very important due to algal species, again, being primary producers. P minimum numbers decrease due to antimicrobial peptides expanding non-motile cells, so it's harder for them to move around, and they destroy cell membranes and the intracellular materials. However, a complete lysis of P minimum takes way longer than less harmful species. A complete lysis of P minimum can take anywhere from 1 to 2 hours. Meanwhile, for any less harmless species, it can take a few minutes. This is due to dinoflagellates having a cellulose cover over the plasma membrane, making it harder to break down. Not all dinoflagellates have this, but some of them do. Another solution is moderating pH. Now, the Chesapeake Bay has an average pH range of 8.7 to 9.25, while P minimum growth ceases at a pH of 9.6. That is quite close to what P minimum can reach before it ceases growing and existing. Now remember, the goal is not to get rid of these dinoflagellates, it's just to moderate them. So as stated, nitrogen concentrations in our oceans are rising due to human pollution on our own planet. As pH increases, inorganic nitrogenous compounds decreases. However, increasing pH can also cause gill surfaces to absorb more ammonia, lowering its dissolved oxygen and increasing its sensitivity to ammonia in the future. While increasing pH can be a positive thing, anything in high dosages can be dangerous and should be moderated, especially under scientific circumstances. So, in conclusion, most research studies have believed that human pollution is the main cause of algal blooms that become more toxic, not the primary producers themselves. Just like everything in science, everything should be in moderation. P minimum are incredible primary producers when it comes to the food chain of our oceans, but too much of them can cause a detrimental effect on most organisms in our waters, especially those exposed to algal blooms. Too much pH can be a bad thing. Too little pH can be a bad thing. Just the right amount of pH can cause the ecosystem in our water to survive better. Humans did create the problem, and it is our responsibility to fix it. I hope we can find more research opportunities to fix this issue because it has become more abundant over the years, and it's not looking like it's slowing down. So I hope more research can be put into it, because without it, it seems like this problem will never go away. But as stated before, here are the text references. I left a research reference at the top. The main focus of this presentation was on this research paper, and these are some other references I used to help me along the journey of figuring this whole topic out. And the pictures I showed before, including result charts, the food chain, and the P minimum blooms, are here. You can go ahead and check out these links or these articles. They're also in the text references. Feel free to check out these articles. They're really great reads. They taught me a lot going through them, and I hope they do the same for you. But anyways, that does conclude my presentation. I hope you learned something that you didn't know before, and if you have any questions, please feel free to leave them in the comments below. And I hope everyone has a great day. Goodbye.